Venus is the second planet from the Sun in the solar system and one of the brightest celestial objects in the night sky, second only to the Moon. In folklore, Venus is often called the morning star when it appears before dawn and the evening star when it appears after sunset. What makes Venus particularly intriguing to scientists is its striking similarity to Earth in terms of size, mass, and internal structure. Both planets have a rocky crust, a metallic core, and a solid surface. Because of these similarities, scientists often refer to Venus as Earth's sister planet. However, what happens on Venus is entirely different. It is a scorching inferno with extreme temperatures, crushing atmospheric pressure, and a suffocating atmosphere filled with toxic gases. Studying Venus not only expands our understanding of the universe, but also provides crucial warnings about Earth's future if environmental protection is neglected. Venus is located between Mercury and Earth, about 108 million kilometers from the Sun. It has the most circular orbit among all the planets and almost no axial tilt, resulting in a nearly uniform climate across its surface. Venus has a diameter of approximately 12,104 kilometers, only about 650 kilometers smaller than Earth, and its mass is about 81.5% that of Earth. However, one particularly unique feature is its rotation. A day on Venus, the time it takes to rotate once on its axis, lasts a staggering 243 Earth days, which is even longer than a Venusian year. 225 Earth days, the time it takes to orbit the Sun. Moreover, Venus rotates in the opposite direction compared to most other planets in the solar system, a phenomenon known as retrograde rotation. These unusual characteristics make Venus a mysterious planet that has fascinated astronomers for decades. The atmosphere and harsh climate conditions. The climate on Venus is a prime example of an out-of-control greenhouse effect. Venus' thick atmosphere is composed of 96% carbon dioxide, along with small amounts of nitrogen and toxic gases such as sulfur dioxide. The dense clouds covering the planet are primarily made up of sulfuric acid droplets, creating an extremely corrosive environment where life, as we know it, cannot survive. The surface pressure on Venus is 92 times that of Earth, equivalent to the pressure at a depth of nearly 1 kilometer below the ocean's surface. This makes any exploration equipment, unless specially designed, be crushed within minutes. The average surface temperature reaches 470 degrees Celsius, hot enough to melt lead, and remains constant day and night due to the thick atmosphere's highly effective heat retention. Venus is the hottest planet in the solar system, even hotter than Mercury, despite being farther from the Sun. These conditions make Venus a true planetary hell. Surface structure and geological activity. The surface of Venus is hidden beneath thick clouds, making it impossible to observe with ordinary telescopes, but radar probes have revealed many important details. The planet has a diverse terrain with thousands of large and small volcanoes, many lava plains, and mountain ranges that rise thousands of meters. Although there is no clear evidence of current volcanic activity, recent observations from the Venus Express mission by ESA suggest there may be signs of volcanic eruptions in the recent past. Unlike Earth, Venus does not have tectonic plates that move, but this does not mean the planet lacks geological activity. The absence of a global magnetic field is also a significant question, as it suggests that Venus' iron core does not rotate or generate a dynamo effect like Earth's. This makes Venus vulnerable to cosmic radiation and solar winds, raising major questions about the planet's formation and evolutionary processes. The importance of Venus to Earth and space science. Although Venus currently has extremely harsh conditions, It plays a crucial role in studying Earth's climate. By comparing Venus with Earth, scientists can better understand the consequences of a runaway greenhouse effect. On Earth, if CO levels rise uncontrollably, we could face a future similar to that of Venus. Additionally, analyzing the atmospheric and geological composition of Venus helps us gain deeper insights into the formation and evolution of rocky planets, including Earth. Some hypotheses suggest that Venus may once have had oceans and habitable conditions before global climate changes led to its current state. If this is true, studying Venus could help us understand why Earth can sustain life, while its sister planet cannot. From a technological perspective, developing spacecraft capable of withstanding Venus's extreme environment would mark a significant step forward in our journey to explore the deeper universe. Was there ever life on Venus? The question of whether life ever existed on Venus is one of the greatest mysteries in astronomy and planetary science. Today, Venus is a deadly planet with extremely high temperatures and an atmosphere thick with CO, but there is growing evidence that in the distant past, it may have had a more temperate environment, possibly even liquid water on its surface, a key ingredient for life. In the following, we will explore the hypotheses, scientific evidence, and ongoing debates surrounding this intriguing question. Evidence of Venus' milder past. Some climate models suggest that 2 to 3 billion years ago, Venus may have had liquid water oceans on its surface and a temperate climate similar to Earth. Data from space missions, particularly ESA's Venus Express and recent NASA studies, indicate that Venus' atmosphere may once have contained less CO, allowing liquid water to exist for an extended period. If true, Venus could have had suitable conditions to support microbial life, much like how life first began on Earth. In addition, scientists have analyzed the hydrogen isotope ratio in Venus' atmosphere and discovered that the planet may have lost a vast amount of water into space. The presence of deuterium, a heavier form of hydrogen in high proportions, suggests that water once existed on Venus but gradually evaporated and escaped into space due to solar wind. This implies that Venus may once have had enough water to form large seas or lakes. Why did Venus become a hellish world and destroy potential life? If Venus once had water and a mild climate, the important question is, what happened that turned it into the harsh planet we see today? Scientists believe that a runaway greenhouse effect is the main reason Venus became a hellish world. As the sun gradually became brighter over hundreds of millions of years, Venus' surface temperature slowly increased. This caused surface water to evaporate into the atmosphere. Water vapor is a powerful greenhouse gas, and as more water evaporated, it trapped more heat, further raising the temperature. This process created an irreversible feedback loop that eventually caused all water on Venus to evaporate. With no water left to absorb carbon dioxide, CO accumulated in the atmosphere at extremely high levels, intensifying the greenhouse effect even more. Additionally, Venus lacks a strong magnetic field like Earth's to shield its atmosphere from the solar wind. As a result, water molecules were broken apart into hydrogen and oxygen. Hydrogen, being lighter, escaped into space easily, leading to permanent water loss. Could life still exist somewhere on Venus? Although Venus' surface is too extreme for life as we know it, some scientists hypothesize that bacteria might survive in the planet's upper cloud layers. At altitudes of about 50, 60 kilometers above the surface, temperatures range from 30–50 degrees Celsius, and atmospheric pressure is similar to Earth's. This region is where some scientists believe acid-tolerant microorganisms could potentially live, similar to extremophile bacteria on Earth that thrive in acidic environments like hot springs or deep-sea volcanic vents. In 2020, a groundbreaking discovery was announced. Scientists detected phosphine in Venus' atmosphere, a compound typically associated with life on Earth. On Earth, phosphine is mostly produced by anaerobic bacteria or through industrial processes. This finding raised the question, could microbial life exist in Venus' cloud layers? However, follow-up studies have not yet confirmed the origin of the phosphine, and it remains a topic of scientific debate. Future missions searching for life on Venus. In the coming years, several missions are set to explore Venus in greater depth to uncover its past and the possibility of ancient life. Key upcoming missions include NASA Da Vinci Plus, 2029, 2031. This mission will send a probe into Venus' atmosphere to analyze its chemical composition, aiming to determine whether water may have once existed on the planet. NASA Veritas, 2030s. Using high-resolution radar, this mission will map Venus' surface to study its geological history and look for signs of recent volcanic activity. ESA Envision, 2030s. The European Space Agency's mission will focus on geological and climate processes to understand why Venus lost its water. These missions could help answer crucial questions. Did Venus once have surface water for long enough to support life? Could microbes exist in the planet's acidic cloud layers? Most importantly, these discoveries may provide insight into Earth's future and the nature of exoplanets across the universe. Venus is a planet that is both familiar and mysterious within our solar system. It shares many similarities with Earth, yet harbors an extremely hostile environment. Although it cannot support life today, studies suggest that Venus may once have had water and a temperate climate, with the potential for microbial life. Researching Venus not only helps humanity better understand the formation and evolution of rocky planets, but also serves as a powerful warning about the consequences of climate change on Earth. Venus stands as a vivid testament to the devastating effects of a runaway greenhouse effect, a future that Earth must strive to avoid. Thank you for watching the video. Don't forget to subscribe to the channel and turn on notifications to watch more new videos as soon as they're released.